Good day. So this video is an extension of the last one that had a PowerPoint looking at the first kind of calculations we're going to do. These are going to be the simplest calculations you run into in the section. And I just found it easier to show how to do the work in this format rather than the PowerPoint. So you can write out these things on a separate sheet of paper, or you can fill them in right on the PowerPoint notes for each question. So we look at question 1. We're given an equilibrium reaction, we're given a temperature, and we're asked to find the KQ. It actually wants us to do it twice, we're just going to do it once. For some reason they want to show everything as powers of 10 to the minus 3, so that's why you have some non-standard scientific notation here. But we're just going to use these three values. So first thing is we write out our KQ expression, and then we say, oh, there's the HI. So that number is going to have to go in for the HI. We're going to have to square it. There's the H2, and it's going to go in there. And there's the I2, and it's going to go in here. So once we've done that, we go boom times boom divided by bam. Make sure you square it. And we get 0.0183. Hopefully my calculator is working. Always double check. You never know what I'm doing. Number 2. Same kind of question, different equilibrium. So we have the equilibrium in the formation of ammonia. We're going to start out with a KQ expression, and then we just make sure we pop these numbers in the right spots. We got to remember to square the ammonia concentration and cube the hydrogen concentration. So on my calculator, I go 84.3 and I square it. I divide by 2.12 and I divide again by 1.75 cubed. If I do it in that way, if I divide and then divide, I don't have to use all the brackets. But if you prefer the brackets, that's fine. KQ comes out as 625. So you can see these are fairly quick. These are not difficult. Number 3, we got the same reaction, different temperature, different KQ value. This time we're given the KQ, we're given the concentration of the nitrogen, concentration of hydrogen, but we're asked to find the ammonia. The nice thing is we're already at equilibrium. That makes the calculations a lot easier. So we write out the KQ expression, but now we have to rearrange it because we have to isolate the NH3. So the NH3 squared is going to equal KQ times those beasties, and we just start plugging in numbers. Don't forget to cube. And so our NH3 squared is 0.010 by the time you get through those calculations. But we don't want the square of it, so we take the square root of this, and we take the square root of that, and our NH3 comes out at 0.10 big M. So that's a case where you were given KQ and had to find a concentration of something else, but it's not difficult. You just have to rearrange your expression. Number 4 is the same kind of question. So you're given a KQ, you're given the concentration of the other beasties. That's going to look a lot like the last one. I could have done one where I asked you to find these things, so the SO2 if I wanted it, we've gone up there, KQ comes down there. But it asked for the SO3. So we rearrange, and that means those things hop up there. Then we're ready to substitute. Here's the 85.0, and here's the 0.050, and here's the 0.0500 cubed. We get this tiny number, and then we square root it. And then we get our 0.0230 big M. So I got 4 examples right in this video. Didn't take long because these questions are easy. As we go along, the questions will become more difficult.